Using EISPP, we can also access applications that make use of data displayed related to the graphs. We can click FreeCAD to open up a CAD program that has made it interoperate in EISPP. Here we see a modified screenshot of FreeCAD where a wheel of the car is highlighted with the label wheel_of_car. The ontology row with the car_part_of.l as the ontology has been added. Here's the screenshot of FreeCAD before the edit. To be interoperable in EISPP, the database in FreeCAD must map to a common reference data library. This reference data library can then map to other applications. In this way, each application can call things whatever they want and still have interoperability. For example, FreeCAD may store everything in database A. Database A has columns labeled by lowercase a through e. The column labels A through E are mapped to the A' through E' terms in the reference data library. These reference data terms are then mapped to label A" through E" for the columns of database B. Database B can then be used by other applications. Moreover, the reference data library mapping from database A can map to database C, D, E, etc. or any number of databases used by each application. Like the directed graph in the previous slide, there should be both an ontology and a reference library. In this case, WordNet is used for the reference library, and the main ontology is the car ontology from the W3C simple part-of ontology example. The ontology may actually be multiple ontologies, such as one or more upper ontologies with mapping between them and multiple domain ontologies. Common upper ontologies include OpenSite and UMBL. Likely ontologies for engineering applications such as CAD will be the Express-G schema, which is like an upper ontology with multiple domain ontologies. It is more complex than the simple -part-of ontology, but it still offers merological or part-of relations. Express has already been used with the ISO 15926 standards for oil and gas. An excellent demonstration of this work is the semantics project by VTT in Finland. Express has also been considered for the PLCS standard, ISO 10303 AP239. It has applications to aerospace and defense, and work has been published for the standard as late as October 2013. In addition, the PLCS standard bases its approach on ISO 15926's approach to reference data. Thus, consideration of both standards seems reasonable. I may want to add a microblogging application to EISPP. In this case, I will use Simba developed by Andre Sombre et al. To do this, I click on Applications to bring up a menu for editing applications. I search for Simba and see it appear in the menu. I can then select Simba. Then I can select Codeaster and substitute to substitute my selection of Simba for Codeaster. Clicking OK performs the substitution. I can now select Simba to open it. Here is a screenshot of an installation of Simba, or client-integrated microblogging architecture. It is a decentralized architecture with no central server. The data and the presentation are decoupled, meaning that the data and presentation can exist in separate places. In fact, in Simba, each person can host their own data on their own server. What you see for the presentation would be the same if you chose to use the layout that Andre Sombre chose. In this instance of Simba, data is stored at rww.io, which is a linked data server. Here it seems that each directory is a linked data platform container, and each RDF file is a linked data platform resource. According to the linked data platform recommendation, a container in the linked data platform is a place to put a collection of linked documents. A linked data platform resource seems to be essentially a file. Basically, it seems to be file hosting utilizing linked data. Here is a view of post 1, the first RDF file. Moving up one directory shows an RDF file describing who I'm following. I can also click on Etherpad to load it from EISPP. I can add instances of an ontology in what I'm writing to tie it with the graph showing contributions to a car. I can select the car underscore part of.l ontology in the menu bar, and the class hierarchy for the ontology shows up on the left. Here is a screenshot of Etherpad before the edit. References include semantics : open simulation platform, https : //www.semantics.org /semantics /documents /semantics with the S capitalized underscore presentation with the P capitalized underscore 17 underscore compressed.pdf link data platform 1.0 W3C recommendation 16th of December 2014 http //www.w3.org capital T capital R /LDP Etherpad http etherpad.org FreeCAD http www.freecadweb.org simple part-whole relations and OWL ontologies W3C editor's draft 24th of March 2005 http www.w3.org /2001 /SW /best with B capitalized practices with P capitalized no space between best and practices capital O capital E capital P simple part whole with the S, P, and W capitalized simple part whole relations V1 period 3 period HTML Raphael Bates et al. An upper ontology based on ISO 15926 http www.nt.ntnu.no users SKOGE PROST proceedings escape 15 papers capital I capital A -027 .pdf Andre Sombra et al. Simba client integrated microblogging architecture decentralized information group MIT C-Cell Qatar Computing Research Institute Introduction to ISO 15926 Viatech October 2nd 2011 PLCS Lib http www.plcs.org /PLCS LIB /PLCS LIB /